Welcome to the Lippert Technical Institute. My name is Mark, and in today's video we are going to be digging a little deeper into switches. Now, I don't know about you, but when I first started learning about switches, sometimes it felt a little overwhelming because of not only how many different types there are, but the different ways that we're going to troubleshoot them as well. So in today's video, I want to cover some of those things. We're going to talk about different types of switches, how they're wired, how do we know if it's bad, and I'll give you a little demonstration with my tabletop mock-up. Regardless of what type of switch we're working with, all of the same fundamentals surrounding it will apply. So if you are using switches for a 12-volt system or maybe a 120-volt system, all of the same things are true about them, and really the easiest way to boil it down is that they are either connecting a circuit when they're on or they're disconnecting it when they're off. In front of me, I've taken a simple 12-volt light that I want to demonstrate this, and we're going to move on to a different tabletop mock-up to show you some of the other switches and how to troubleshoot them. But one thing you need to know about switches, they are either going to be ground-based or they're going to be power-based in 12-volt systems. So if we look at my switch here, we can see that this one is going to be power-based, and the easiest way to think about it is we are going to connect to our power source. It's going to run all the way to our switch, and when the switch is in the on position, it's going to make its way all the way to the light. This means that it is creating continuity, and if I turn it off, it is breaking continuity, and that is why the light will turn off as well. So I'm going to go ahead and connect this to my drill battery, and I will demonstrate this. I have the power into our power, I have our ground into our ground, and just by activating our light, I create the continuity, and this means that my switch would be healthy. So one of the things we're going to talk about is how to test the switch when it is bad. It typically means we are going to measure continuity at the switch itself. This is a setting that you're going to have on your multimeter, and each meter is just a little bit different. So we'll talk about that as we go, but to recap that, when a switch is in the on position, it is creating continuity on either the power or the ground side, whichever it's wired to, and when it's in the off position, it is breaking that continuity. The sign of a bad switch might be that when it's on, it's not activating that continuity. Therefore, we would condemn it. And we're going to talk about how to do that. But this is one of the core fundamentals. This is what we're going to apply to all of the other switches in today's lesson. Let's have a look at some of the switches I have for you in this mock-up. Now, really, I went with the main 4 types of switches that you're going to see and that are most commonly wired, troubleshot in a lot of different walks of life. So over here, we have what is known as a momentary relay. What this means is we are only creating that continuity while the button is being pressed. And truth be told, these are going to be most common in things like car starters or whatever the case might be. And troubleshooting them is really just making sure that we have continuity as long as the button is pressed. So on this mock-up, you'll notice if I press the switch, my light will light up. And this means that I have a signal passing through the light, it's able to light up, and then when I let it go, that switch is going to power off. But what would we do in the instance that it did not light up? Well, troubleshooting them is really going to be as simple as taking our multimeter. We're going to go to your ohms setting, or maybe you have a continuity setting. Every meter is a little bit different, that's okay. On this particular meter, you might see a 0, or it might say OL, meaning open line. That's the same as saying there's no continuity. So you'll notice what happens to the meter when I activate my switch and then I connect my 2 probes. I activate my switch, and now we can see that I do have continuity. Now, of course, I can tell that because I can see the light up, but this is a great way to troubleshoot, and this will let you know if your switch is healthy. The next type of switch we're going to go over is what is known as a single pole double throw switch. Now, switches are often referred to in terms of poles, P-O-L-E, and throw. Pull is in reference to either a power or a ground signal coming to it, and throw means it's going to send that to one or maybe two places, like I have in this instance. Now, this single pole double throw switch will always receive its power signal right to the middle. So if you look at the switch I have here, you'll notice I have 3 female spade connectors. The one in the middle, this is going to be our power, and then the ones to the outside, when you wire them, these are what's going to go to your light. Now, troubleshooting these is a little bit counterintuitive because where we are going to probe for power doesn't necessarily feel like it's where it should be. However, if you stick to probing the opposite side of the switch, we should be A-OK. So as I demonstrate this, I want you to notice that if I rock the switch one way, it's going to activate, we'll call it light number 1. If I rock the switch the other way, you'll notice that it's going to activate light number 2. Now when I troubleshoot these, let's say I activate the switch to the left, I am going to probe the middle and the right side of the female spades. And what I mean by that is right now it's rocked to the left. I would then take my meter and probe the middle and the outside. And what I'm looking for is that I have that continuity. Now you can see that the light is on. We know that we have continuity, but in the instance that it did not come on, this is how we're going to troubleshoot it. If you probe to the same side that you are turning the switch, we might not have any continuity at all, and it would reflect as though I have a bad switch. So keep that in mind. Sometimes the results are mixed, but this is going to be the very best troubleshooting for a single pole double throw switch. Next, I want to talk a little bit about latching relays. This is far and away the most common type of switch and one that we're all very familiar with, both at home or whatever the case might be, something like a light switch. This is going to be an example of a latching relay. But where did it get its name? Well, simply put, a latching relay is going to latch into place when it is either in the on position or the off position. We can see here I have a light connected to my latching relay, and really if I turn it on, we can see that it has then created continuity. We don't troubleshoot it in a manner that's any different than the others. We are going to use the continuity setting, and just like we did for the momentary switch, we are just going to touch both spades, and if we have continuity, it means the switch is healthy. If this were to be in the on position and we don't have a light that is lighting up, if we were to, let's say, change the bulb like you might do at home and it still didn't light up, maybe we need to figure out, is that switch still capable of creating continuity? And to do that, I'm just going to take my 2 probes. I am going to carefully touch the spades on the back. And you'll notice on my meter, I will have continuity. Now, one thing that I do get asked a lot, Mark, what do the specific readings when measuring continuity represent? And is one more healthy than the other? And I think that's a phenomenal question. If you have a very low number when measuring ohms, it means we have a very low resistance. And for things like wires or for things like a light switch, this is going to indicate that energy is capable of passing through it freely, or a ground signal, whatever the case might be. If your meter has a very high resistance, maybe it could indicate that there's some sort of damage and we'd need a little bit more investigation. If it has that OL, once again, this is open line. This is no continuity, and then we would replace that switch. We are now going to talk a little bit about the double pole double throw switch. So you remember earlier when we talked about poles and throws, the single pole double throw got a power or a ground signal right to the middle post, and then it had 2 separate outputs to activate 2 different things. Well, the double pole double throw switch has a very specific purpose, especially in the RVing world, is that it's going to operate dual polarity motors. Now you're going to find these most often on things like awnings, on things like landing gear, or maybe on a slide out. And the idea is that motors can run in 2 different directions. They do so by getting power and ground one way, and then when we rock the switch the other way, they get ground and power the other way. So it just crosses the signal. Now, there's a couple of different ways to wire these, and what's most important to know is it really depends on whatever type of application you are using. But Far and away, the most common you're going to see are power and ground going to our two middle posts. And then you're going to have two outputs from the switch. Usually these are going to go to your motor. There's a couple of different ways for us to test this. You could use continuity, just like we did on the single pole double throw switch, measuring the posts opposite of the way we're rocking it. Or you can actually test with voltage. That might be a more clear-cut way to understand, is this passing the voltage through it? Maybe if the switch was broken, it wouldn't be, or maybe we have a voltage loss. This could indicate that the switch is bad, but that's how I recommend you do it. So as I rock my switch, you'll notice this awning motor will turn in one direction. Now the beauty of this switch is that going the other direction, I can turn the motor the opposite way. So I'll push it there. And this is why these types of switches are so effective. You could imagine if you had an awning and it was connected to this latching relay, when we hit on, that it would extend and it would never come back. So we have to have a way to bring it back. That's where the double pole, double throw switch comes into play. And to test them, all we have to do is touch the two posts, let's say on the output. And then as I rock my switch, you'll notice I have a voltage that should go between positive. And if I rock it the other way, it should go the other way. This means that my switch is working properly, and it's how I recommend you troubleshoot a double pole, double throw switch. That'll do it for today's video on switches. Thank you guys so much for joining as we went through how to troubleshoot a momentary relay, a single pole double throw, a latching relay, and a double pole double throw. The troubleshooting was all the same. And remember, if your switch is broken, switches don't get stitches, they get replaced.